Okay, section 13.3, factoring trinomials with ax squared plus bx plus c. What we're going to notice is that a now, right here, all that means is there's not going to be a leading coefficient of 1 always anymore. Now we're going to have a leading coefficient of almost any other number. Okay, so let's come in here and just kind of get started. Okay, we're going to use the trial and error method to factor trinomials and use the AC method. I'm going to be completely honest with you right now. This method right here, though I'm going to show you how to use it, I fully expect you to go straight to the AC method. Matter of fact, after this lesson, I will probably never use this method ever again. But I would be remiss as your math teacher not to show it to you. Okay, guidelines for the trial and error method. If the sign of the constant term is positive, the signs of both factors will be the same, either both positive or both negative. Okay, remember that's the C term. If the sign of the constant term is negative, the signs of the factors will be different, one positive, one negative. Remember we learned that in the last lesson. Okay, let's look at this first one here. Using the trial and error method to factor each polynomial, and I've got the other polynomial on the other page here. Okay, this one's going to go pretty straightforward. There's really not too much guess and check here. One, because 5 is a prime number. So let's think of our factors of 5 real quick. Okay, well, factors of 5 are going to be 1 and 5. Okay, notice he's positive. Well, also this 6x is positive, so we know that both of these are going to be positive. And we can come straight in here and go, okay, well, how about x? I'm going to put my parentheses down. X, and then I got plus 1 and plus 5. Okay, that's factored, straightforward, simple. Okay, but that is with a leading coefficient of 1. Okay, let me come over here and we'll start this next one. Okay, I'm going to work it out very slowly, very intentionally, and just, you can see why it's not used very often. Looking at example 2, okay, now we're going to factor each polynomial. Okay, look for the greatest common factor, okay, but notice real quick that there's nothing here that we can factor out to make this guy look anywhere normal where it's going to have like a leading coefficient of 1. Can't factor out 4s because of that 15. The x's, they've got to stay. Okay, so this is how this is going to work. Okay, so what we're going to do first is let's look at this guy right here. Okay, well, we'll call him like say the front. Okay, the front is going to be 4x squared. Okay, well, let's think of his factors. Okay, well, he can either have 4x times x, okay, that would create a 4x squared, or, okay, we could have 2x times 2x. Those are two factors that will create him. Okay, now let's come in here and look at the 15. Okay, not only does the 15, okay, we'll call this the last side, or the left, or whatever you want to call it. It's not even the left side, okay? The left side is going to be, the last side is going to be this negative 15. Well, what are his factors? Now, here's where it's going to get a little weird. You got to think of all his factors, okay? So how do we create a negative 15? Well, we could have negative 15 times 1. That's 1. Well, what's another one? Well, we could have negative 1 times negative 15. That's another, okay? Well, notice that's not the only factors of 15. We can also come here and go, okay, well, how about negative 3 times 5? Or how about 3 times negative 5? Okay, any one of these will work. Okay, so that's what we need. Now what we're going to start doing is we're going to start playing around with things and to see if things are going to work. So what we can do here is like using, let's just say, this guy right here. I'll do this in blue now. Okay, let's take this first guy here and I'm going to put 2 parentheses here. Okay, I'm going to put 2x in both of them. Okay, and then what I'm going to do is I'm going to take this very first one here. I'm going to take this negative 15 right here. Let's see. This guy here, notice that's a negative 15 and that's a positive 1. Okay, well, I'm going to put them in there. I'm going to put this minus 15 and I'm going to do a positive 1 here. Well, does that work? Okay, well, let's find out. Okay, what we're going to need to do is we're going to start multiplying these together. notice here, okay, I can multiply these together and I'm going to get 2x. When I multiply these together, okay, I get what? Negative 30x. Well, then what I do is I'm going to look here and go, I've got this 2x, and I'm going to subtract this 30x. When I do that, when I do this, let me get that correct there. When I do 2x minus 30x, I get negative 28x. It's not the right middle term, okay? I can't use that one. So this is wrong. So let's come in here and we will keep trying. So we've used the negative 2. Let's kind of keep going here. I'm going to go to the next page. Let's try again. Okay, this time what we're going to do is I'll go ahead and use the 2x again. Okay, so let me go and rewrite everything out again. I'm going to use the 2x again. Okay, but this time I'm going to go ahead and just, like I said, it's guess and check. How about I use the negative 3 and then the positive 5? Will that work? Well, I don't know. Let's check it out. So I'll come over here and I get 2x times 5 is going to give me 10x. And then negative 3 plus 6 is going to give me, and I do this here, that's going to give me the negative 6x. Well, 10x minus 6x is going to equal 4x. But notice, okay, that's a positive 4x. I'm looking for a negative, okay? So now what I can do is, look, I know I'm zeroing in on it now, okay? So how about I just switch signs, okay? Let's do this again. I've got 2x, okay? Instead of negative 3, let's do the positive 3 this time. And then on this other 2x, let's do the negative 5, okay? Come in here. I'm still going to get this 10x here. So I'm going to get a negative 10x. And then here, I'm going to get a positive 6x. Well, negative 10x plus 6x is going to give me a negative 4x. So I know once I create this middle term here, then I have the correct, okay, combination of things, multiples and everything else. And so therefore, this right here would be my factored form of this quadratic equation. So that's how that works. That is the guess and check method, trial and error, whatever you want to call it. Okay. Going to show you a different way now. Okay. To me, it's a little bit simpler, but you know, some people do fall in love with the trial and error method, and more power to them. There is nothing wrong with that. Okay. Now what we're going to start doing is what we call the AC method. Okay. Okay. So step 1. We're going to multiply A and C. Okay, example here. A and C. 2 times 10 is going to give me 20. Being very aware of the signs. Okay. Step 2. Find two integers whose product is A and C and whose sum is B. Okay, if it's not possible, then the trinomial is not factorable. Notice, find two integers whose product is 20 and whose sum is 9. Okay, 4 times 5 is 20. It's the same thing what we did, okay, what we did earlier. Okay, rewrite the term bx using the two numbers found in the middle. Notice you're going to get 4 terms. This is why we've learned how to factor 4 terms. Okay, and then factor by grouping. Okay, just like you just saw. That's how come we did the practice of factoring by grouping. Okay, we'll find the GCF, factor it out. And then notice what we did from the last section, pull out that x squared, you're going to be left with 2x plus 5. And there we go. Okay, just like I said. So let's do a couple of these. We're going to do a bunch of AC methods, okay? I'm only going to do one right now, but we'll do a bunch in examples. Now, you can do the trial and error method. But here, let's just jump straight in and look how easy this is. Okay, what I always do in this, and I'm going to get the red one out. I've got A, B, and C. And since I'm doing the AC method, I'm going to do 3 times 6. Well, I've got these are positive, so it's going to be 18. Well, let's start thinking of all my multiples of 18. I've got 1 and 18. Okay? I've got 2 and 9. I've got 3 and 6. Okay? And So do any of these already start looking like, okay, these are all multiplication here, but do any of these look like they could add together to create 19? Well, yeah. This guy there, okay, that's going to be a positive 1 and a positive 18. Okay, here's the difference. We don't have a leading coefficient of 1 now. So what we're going to do is we're going to create these guys and put them in for the 19. Here's how that's going to work. Change colors here. Rewrite this as 3x squared. Okay, that's a positive 1, which you're going to have to add an x to these. So we're going to go plus x. I'm not going to worry about the 1. Then plus 18x, and then plus 6. Okay, notice all I did was I just switched out the b for these multiples here. Okay, so I've kind of just created my b, just a factored version of it. Okay, or multiples of it. Now, I've got 4 terms. Group it. Look at the first one. The only common factor I have here is an x, so I can pull out an x, and then I can divide everything else by x. Well, here the x cancels, okay, and I'm going to be left with 3x. Here the x is reduced, and I'm just left with a 1. Okay, let's look over here. Is there a common variable? No, these both don't have x's. But how about we pull out a 6? Okay, that's going to be a positive 6. So if it helps you, put positive 6 there. That's fine. And then divide everything by 6. Well, 18 divided by 6 is going to be 3. Don't forget the x. It doesn't reduce out. And then 6 divided by 6 is just 1. Okay? And then a good telltale sign you did this correctly, these guys right here are going to match. Okay? If they match, you did it correct. You can always go back and double check. Well, let's finish this off. We've got 3x plus 1. Okay? And then notice I've got this x here. And then I've got this plus 6. And there's your factored form. Personally speaking, so much easier than the trial and error method. Okay? But I'll be honest, people who get good at the trial and error method can do this part pretty quick because they start seeing different factors. I never really paid it no mind. So, okay, tips to keep in mind while factoring. When factoring polynomials, always look for the greatest common factor. Let's get some colors out here. Always look for the greatest common factor first. Then if there is one, remember to include this common factor as part of the answer. That means like when we factor something out, it's still got to be there somewhere. To factor completely means to find all the factors of the polynomial such that none of the factors are themselves factorable. Okay? Not all polynomials are factorable. We've seen that. Factoring can be checked by multiplying the factors. The product should be the original expression. That means just distribute it all back together, FOIL it all back together. Okay? And then note, no matter which method you use, the AC method or the trial and error method, factoring trinomial takes time, okay? And then notice practice, okay? You'll become more efficient with either method. Make sure to be patient and observant, okay? Just take your time. Make sure for a while you might want to distribute it back together, but go ahead and just double check it.